Hi everyone, welcome to the Code Ninja Spaces. It's our eighth episode. So our first news is about AGI. What happening is basically there are some bold claims. Elon says that 2026 will be the year of singularity. What does it mean? It means that artificial intelligence will be more than human intelligence. And at the same time, leaders at Anthropics are saying that the term AGI will become obsolete. These are two extremes. So Umar, what are your take on it?
So, uh, so AGI means that artificial general intelligence. This means like uh, computer can do, a model can do a lot of tasks that humans can do. So it's more of like generalization aspect of a human brain. Like for example, you think about like I can talk to you, I can walk, I can I can be very good in math, I can create music, I can drive a car. So this is one human who is doing a lot of different tasks, right? So this is, for example, initially AGI means like we would improve the model performance in a way that it can perform like human. And when you talk about like human, I mean already models perform in some areas far better than humans, right? Even computers, even before AI, computers used to perform far better than humans. It's about the generalization aspect of it. And one of the hardest thing to crack historically was language. So
Hmm.
language, you see, models have cracked language. So in some aspect, it is AGI, right? So because they have cracked language. But yeah, that's one part. That's one part. Like what does AGI mean? And then once we have established AGI, is really is that generalization aspect of model performance. Like you can generalize across lots of different things.
Hmm.
If this is so that's one thing that we've established for AGI. Is now there are two parts. One is like, have we already achieved AGI, or it's just a very concocted term? It does not exist. It means nothing. So I
Hmm.
think both views exist. So for example, one view is like, yes, we have to achieve AGI, and there has to be a North Star. So what does that actually mean? So Sam Altman, while talking with David Dutch, said like, if AI can prove quantum mechanics. So would
Hmm.
that mean that we have achieved AGI? He said yes. So that's one way of looking at. And the other is that we have already achieved AGI because we've already achieved AGI because it has cracked language. So this is these there's a bit of a dichotomy. But the real thing, I think, the question as an engineer we need to ask is like, I mean, this thing by Jake Cooper. Jake Cooper is the CEO of Railway. It's a cloud infrastructure company, right? Railway is
Okay.
not like railway; it's a cloud infrastructure company. And
Hmm.
he had this so he gave Claude a system specification which he personally theorized over 5 years, right? So imagine you've been working on some theory for 5 years, and then model produced a complete distributed runtime in Golang in 4 hours. Not a prototype, Rafia, a working code base. Just think about it. Just think about that. You have in 5 years you have
Hmm.
built. You have think about like imagine 2010 or 2008. You have imagined something like Kubernetes or Docker, right? For 3 4 years, you were always thinking there should be something like this. There should be containerized environment and all that. And AI happened. You gave that theory to AI. AI built Docker. Think about. I mean, one person could, I mean, essentially create a $900 million business. So think about it. Like that's what AI is. So we need to think about this part more than what is AGI and what's not AGI. But that's very exciting. And
Agree
I
with
told you, I have some very extensive prompts that I have theorized from last
you.
5 years, 6 years. Not like, I mean, it's not like that. Now I've seen Jay Cooper and now I'm gonna give you. No, no. I mean, I've actually had those prompts that's basically regarding hyper. So for
Mhm.
example, in the last 6 7 years, one of the things that I've been thinking about is like how to help developers pursue great ideas, like
Exactly.
technical technology ideas, how to solve. So I've had, so think about like Pinterest for software ideas, right? So think about
Agree.
like, so I've had that theory, have theorized all that knowledge base, and then I'm probably going to give you in the next few weeks, and then going to embed it into hyper.
Okay, perfect. So our second news is also related to something we really talk about, self-recursive softwares. So second news is how AI models are showing self-confidence. What's happening basically, the calibration researchers at Rand Corporation reports that Claude models can increasingly estimate whether their answers are correct or accurate before executing code. And this capability is being described as self-reflective confidence as well. So the main question here is how does that's different from hallucination, and why should people care about this?
It's very interesting, Rafa. So so basically this, where do you get these terms, self-confidence and all that? Anyways, so basically what Claude, the scientists at Rand
Mhm.
Corporation shows that like Claude can really predict the outcome
Mhm.
before actually giving the result, right? It's calculating the probabilistic outcome before it executes the outcome. That is very powerful because it means a lot less brute force retries. And when you talk about a lot less brute force retries, it means a lot less token usage, and when it means a lot less token usage, it means a lot less energy,
Hmm.
right? So energy is the innermost loop. So that I think is very interesting. That if somehow you figure out how to somehow a model has that internal innate sense whether what they're doing is right or not,
Hmm.
based on probabilistic way, not in terms of if else. That would be a very powerful thing to execute response in the least token consumption way. So that, and by the way, this is just this is very early version of the results.
Hmm.
Think of it as like intuition emerging from statistics. So that's what for software teams, Rafa, for example, if you're asking in terms of hyper, this probably would collapse QA cycles. You don't need much QA. Just
Yeah.
imagine why do you need QA? Let's question it. Why do you need QA? QA exists. There's one single thing, that there has to be that developers can't produce quality-free software. That's what that's why QA exists, right?
Hmm.
Bug-free, in terms of like in any ways, like whether you were not able to capture the customer requirements right, or you just captured it right, but there were flaws in the code. But think about AI writing the software, and with the ability to predict the software, having that kind of self-confidence, as you like to call it, it would essentially collapse the QA cycle. There won't be any QA anymore, I guess.
But don't you think evals are the QAs for the agents?
Yeah, I mean, yeah, you can think of, yeah. But eventually that cycle would collapse too, I think.
Let's see. But right now, evals are the integral part, so can't say anything.
And
So
we
the
need to
news.
integrate evals in Hyper too.
Yep,
You
I
told
got
me
it.
that you were going to do it.
Then our third news is related to the operating layer agents. So AI is colonizing the operating systems. Agents as the new app. We really discussed app for the Claude, app for the Chat GPT. So what's happening here is these are the news being shared by the Microsoft as well, that the OS layer is the operating system layer is shifting from passive softwares to active agents. What does it mean? They are saying that AI agents are the new app. So what does that practically change now?
Nothing. We knew that already. Microsoft knew it now. So
What?
nothing. So basically, what they're saying is like now they're going to embed agentic AI into the operating system, probably in the Windows or something, right? So they're going to do lots of this agentic AI. They're going to integrate lots of agentic AI experiences at the OS level. So
Hmm.
that's one thing. Already there are so many agents. So BCG, for example, I was reading up somewhere. BCG has 36,000 GPT clones in the organization. Already there are so many agents in the
Oh.
organization. So for Microsoft, if you're releasing Windows, then at the operating system, you're going to use lots of agents
Hmm.
natively that would be embedded into the operating system, right? So yeah,
The fourth news of the day is more related to the hardware. We really talk about this compute, intelligence. So hardware is becoming new bottleneck. It's just like what's happening basically. AI demand is stressing the global supply chain as well. So like why memories are jumping 70% higher? Don't doesn't software supposed to mean to be more cheap? So, but
it's a very interesting topic, Hafim. When you talk about AI, there are two core things: compute, right?
mhm,
Raw compute, like that's required to for the training run, but then inference. Inference is all about memories. Inference is like when you ask the question to model and it answers you at the edge, right? It's inference. So
mhm,
inference is all memory. Your context windows are memories. Long, like I mean, I normally talk. I mean, for example, if I'm driving for let's say 300 or 400 kilometers, I keep on talking in a same session with ChatGPT, wearing these glasses and talking all sort of stuff that's going on in my mind in one
mhm,
session. Why is it possible? Because there's a lot of memory. I have ChatGPT Pro. It's a very long context window. So memory is the bottleneck. Compute is not. Memory is the bottleneck. So Samsung is investing a lot in this. So
mhm,
Samsung is one company who is investing a lot in inference chips. There is a startup called Firoska. It is also trying to create power efficient inference chips. So the opportunity is in system optimization, edge AI, frugal infrastructure innovation. But yeah, I think now we have lots of GPUs, but we need a lot of innovation now at the inference level. So that's why I mean memory is becoming this bottleneck, not hardware, memory.
mhm. Agreed. So the fifth news of the day is more towards logistic, energy, the earth matters are becoming programmable. So what's basically happening is that physical systems are getting and entering into the software feedback loops. So these are the things being shared by SpaceX, Tesla. So the main question here is why does AI suddenly include shapes, batteries, and rare earths? Like when we are talking about AI, we are at the same time talking about batteries and these materials as well.
So really, the question is of a software. It was always possible, like you can build something, launch it, learn from the customer feedback, iterate, then again relaunch. It was never for the hardware, right?
Yep.
So because hardware engineering is hard,
Mhm.
I mean, it's the feedback cycle in hardware. Imagine you build a rocket, and it's not like launch a rocket in 2 months and learn, and right.
Mhm.
So But with AI, and when it comes to AI, it comes to, for example, when think about self-driving systems, which essentially is a software play. So every time a self-driving car does something wrong, it just learns from it, right? So now that physical world uh, has become the same kind of iteration layer that software, the word of software, had always been. So that's what you're talking about. Like it's far more easy. I won't say easy. It's far more. It's far more possible to iterate in the world of hardware, in some sense, not in every sense. I mean, I remember one of my friends is building this mobile device, and he talks a lot about production hell. It's not, I mean, in hardware you can build a prototype, but going to scale is an incredibly hard thing. But yeah, some parts of physical world, let's say self-driving systems or autonomy systems, they are more like software because they are now software.
True. So our sick news is related to biology is becoming editable software. So what's basically happening here is that medical breakthroughs are increasingly more towards computationally driven things. These are the research and things being shared by US Food and Drug Administration, Stanford University as well. So the question here is, and the idea here is that are we talking about reversing diseases like cancer as well? Is there any possibilities? Yeah,
So
ideally they
recently,
have something, but still.
I think perhaps not curing everything, but changing the slope, yes. So, I mean, for example, recently FDA granted this breakthrough status to Direct. It's a company for pancreatic cancer, right?
Hmm.
So basically, giving a breakthrough status means you can put this thing into steroid and you can fast track the whole thing. And this is basically AI-led drug discovery. So
Hmm.
yes, I think it's if you really, Rafa, if you really understand, I mean, biology or computing, whatever. At the end of the day, there's some basic rules that are powering all of these things, right?
Hmm.
We need to understand everything in the world is a computation. Your body, information processing, all follows some very basic fourth grade standard laws. And then when you just and then complexity emerges on top of it, right? Historically, for example, it was very hard for us to understand human cellular structure, right? How cell division happens. I mean, what goes wrong in case of cancer. I think with AI, it has become the first time ever I generally think treating cancer is within human reach. Now it's first time. I think you would see in next 20, 30 years. I mean, my mother died of cancer, right? I have seen how the whole journey of how it takes everything from someone. Um, I mean, first you say, okay, but it is killing. Cancer kills patient every single day, a little bit, right? And eventually you just and when you talk to doctors, because you feel like he's just fine or she's just fine, she's just recovering herself. But the doctors knows exactly what's going on. They know probably 2 years. But I've seen that how painful that is and why I think it's a civilizational challenge. But I think with AI, we and not a general purpose AI, it won't be like large language model would be treating cancer. It's more of like protein folding kind of things, where we'll be just able to predict with a lot more accuracy that what's going on there, and then based on discover
Great.
some drugs and all that. So yeah, I think this is the area that my mother died of it. This is the area I am very passionate about. That what can be done, and the lens I use is computation. I've read and studied Stephen Wolfram a lot. I mean, I don't know if you know Stephen Wolfram, the founder of
Hmm.
Mathematica, Alpha, Wolfram Consulting. So I in the last decade or so, I built that lens of looking
Hmm.
at the world, that computational lens, and it makes physics lot more easier. It gives you that generalized capability to look at the most complex problems. That
Hmm.
if you really see, he talks a lot about Rule 30, where it's in theory of automata. If you, for example, it's some 7, 8 rules, and if you just play with those rules, it just complexity just emerges, right? He talks a lot about second law of thermodynamics. But if you really see what's going on, is very simple computational rules. To understand those rules, I think AI is going to play a lot because human mind cannot process that level of complexity. So currently we are living on top of complexity. My body is basically a reflection of complexity. To transform this body into a very basic rule, I have to I have something that can just dig deeper and come up with that basic rule. I think with AI that's possible. With this company we just talked about, Direction, or this name is very mouthful, by the way. Yeah, but this is exactly what they're trying to do.
Exactly.